Hey guys, welcome back to Collegiate Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick to the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 3 to the power of x is equal to 30. Now to start, 30 we can rewrite as 3 times 10. So now I have 3 to the power of x is equal to 3 times 10. Now, I'm going to go ahead and divide both sides by 3. So these two cancel out. And now I am left with 3 to the power of x over 3 to the power of 1, because anything to the power of 1 is the same thing as itself, is equal to, all that's left is 10. Now, if I have something in the form a to the power of m over a to the power of n, this is going to equal a to the power of m minus n. So, in this case, we have 3 to the power of x over 3 to the power of 1, and this is going to equal 3 to the power of x minus 1 is equal to 10. So now, to solve this, what I'm going to do is I'm going to take the log on both sides. So now I have log 3 to the power of x minus 1 is equal to log 10. Now, if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this is going to equal b times log a. So in this case, log 3 to the power of x minus 1, I can move x minus 1 to the front. So this is going to equal x minus 1 times log 3 is equal to log 10. Now, if I divide both sides by log 3, these two cancel out. Now I'm left with x minus 1 is equal to log 10 over log 3. Now log 10, this is actually equal to 1. So now I have x minus 1 is equal to 1 over log 3. And log 3, this is equal to 2.0959. So now I have x minus 1 is equal to 1 over log 3. 1 over log 3, this is equal to 2.0959. So x minus 1 is equal to 2.0959. Now, if I add 1 on both sides, these should cancel out. Now I'm left with x is equal to 3.0959. So this is my answer. Now to check, my original equation was 3 to the power of x is equal to 30. So now, we know that x is equal to 3.0959. So now if I plug this in, I have 3 to the power of 3.0959 is equal to 30. Now 3 to the power of 3.0959, this is equal to 29.99989, and this is equal to approximately 30. So, meaning 30 is equal to 30. So our solution is right. Alright, so I have 32 to the power of x is equal to 16. So what I'm first going to do is I'm going to rewrite 32, because 32, this is equal to 2 to the power of 5. So now if I substitute in 2 to the power of 5 for 32, I get 2 to the power of 5 to the power of x is equal to 16. Now, if 32 is equal to 2 to the power 5, then this means that 16 is equal to 2 to the power 4, because 32 divided by 2 is 16. So now, I'm going to rewrite this as 2 to the 5 to the power of x is equal to 2 to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 5 to the power of x, that's going to equal 2 to the power of 5x, which is equal to 2 to the power of 4. Now, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, 5x is equal to 4. Now to solve this, I'm going to divide both sides by 5. So then these two cancel out. Now I'm left with x is equal to 4 over 5. So this is my answer. Now, to check, my original equation was 32 to the power of x is equal to 16. So I know that x is equal to 4 over 5. So now I have 32 to the power of 4 over 5 is equal to 16. Now remember how 32, this is equal to 2 to the power of 5. So if I substitute in 2 to the power of 5 for 32, I get 2 to the power of 5 to the power of 4 over 5 is equal to 16. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 5 to the power of 4 over 5 is going to equal 2 to the power of 5 times 4 over 5. And 5 times 4 over 5, these two cancel out. So I'm left with 2 to the power of 4 is equal to 16. And 2 to the power of 4 is equal to 16. So I have 16 is equal to 16. And because this is right, my solution here is right as well. Alright, so our problem here is 5 to the power of x is equal to 6. So right now, just simply taking a glance at this problem, I know that x here, this is going to be a decimal. Because I know that 5 to the power of 1, this is equal to 5, and 5 to the power of 2, this is equal to 25. And 6 is somewhere in between 5 and 25, meaning x is somewhere in between 1 and 2. However, x is a decimal, and it's really hard to just guess for a decimal. So, to find the value of x here, this is my solution. So, I first start with 5 to the power of x is equal to 6. Now, I'm going to go ahead and take the log on both sides. So now I have log 5 to the power of x is equal to log 6. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times log a. So log 5 to the power of x, I'm going to do the exact same thing. And the reason why this property is so useful is because right now we have 5 to the power of x equals 6, and because we know that x is going to be a decimal, it's going to be really hard to find out the value of x just as an exponent. So now, as you can see, once we change the exponent x, once we make it go to the front, it's going to be a real term, and then it's going to be much simpler to solve for it. So I have log 5 to the power of x is equal to log 6. And now if I move x to the front, I get x times log 5 is equal to log 6. Now I'm simply just going to divide both sides by log 5. So then these two cancel out. And now I'm left with x is equal to log 6 over log 5. Now log 6, this is equal to 0.77815. And log 5, this is equal to 0.69897. So now if I divide these two, I get 1.1132827. So this is my answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 10 to the power of 3 minus x equals 1. So whenever we're solving exponential equations similar to this one, we always want to make sure that our bases here, in this case 10 and 1, we want to make them the same. Because let's just say I have a to the power of x, and this is equal to a to the power of y. Well, we know that these two terms are equal to each other or the same, and we can see that both of them have a base of a. Well, in this case, doesn't that mean that their exponents are the same as well? Because if they're different, then that means this would be wrong. They can't be different because their base is already the same, meaning their exponents have to be the same as well. So in this case, if we were to change the bases so that they're the same, then we would know that the exponents are the same as well, so we could just set the exponents equal to each other and solve for x. So we want to make the bases of 10 and 1 equal each other. Well, that means that we have to change one of the bases. And we can't really change 10 to be equal to 1, so why don't we change 1? Well, 10 to the power of what equals 1? 0, right? Because anything to the power of 0 actually equals 1. So we should change 1 to 10 to the power of 0. And this still equals 10 to the power of 3 minus x. Now notice how these two bases are the same, just like this one. And think of 3 minus x as x and the 0 as y. Because these two bases are the same, then that means that these two exponents are the same as well. So we can just ignore the bases for now and just set 3 minus x equal to 0. And now, as you can see, we've created a simple equation using our method. So now, to get the value of x, we're going to have to make it go to the right side. So we're going to add x on both sides. And these two cancel out. So we're left with 3 equals 0 plus x is x. So now we have our value for x. Now, why don't we go ahead and plug it in to our equation? So this gives us 10 to the power of 3 minus 3 equals x. So 3 equals 1. 10 to the power of 3 minus 3 is 0 equals 1. And remember, anything to the power of 0 equals 1. So 10 to the power of 0 equals 1. So we have 1 equals 1. And this is right, meaning our answer of x equals 3 is right.